Hello guys. So basically uh, I'm just gonna do a simple demo and introduction to gRPC Protobuf. So this tool is created by Google a few years ago. It's enabling the network transfer to be efficient as well. So you can communicate to your microservices in a optimized manner. So in the usual microservices, we use, I think most of the companies uses JSON or XML to communicate across different microservices. But uh, XML and JSON are quite huge, especially if you have like thousands of transactions in your across your multi microservices every second. Like for example, a microservice written in Python it wants to communicate to a microservice written in Java or Ruby. Um, Basically, what gRPC does is it converts the request to a binary. It's closer to the memory representation, so it's lesser compared to the JSON or XML. And then the consumer, the microservice that consuming the request is probably gonna convert it into its desired format that the application is gonna understand. So basically gRPC will make it smooth because you don't need to worry about the network bandwidth. um, so yeah, but without further ado, let's start. So I just created a dummy repository. By the way, you can use any of ID of your choice. uh, for me, I use Visual Studio. So yeah, I'm gonna create a virtual environment first. And then you need to install um, two modules, two libraries basically, gRPCIO and then gRPCIO tools. Okay, so now let's just make it large. Make it larger. So now we can start by creating the proto files. I'm gonna create a protos folder. So basically proto files is gonna be the template for your service as well as the schema. So I'm gonna use proto version 3, and then I'm gonna define a service that's gonna be running later in the server. Let's call it cater square root service. And inside the service you need to define methods. You can define methods by specify RPC keyword and the name of the method, which is square root, which is gonna take a number type and returns a result type. And then we can define messages. So this message type is gonna be just input, which is a type of int32. By the way, this number is a sequence in the schema. So whenever you make a call to the service and specifying a data with request, basically gRPC expects you to follow this sequence. Like I can define another um, column here, or like input 2 plus 2. So basically this is considered as tag number 2 in the sequence. So yeah, just an FYI. And then another message called result, which has a field of, say for example, so yeah, so we just defined a service which has one method inside, which is gonna compute the square root. Later we will implement this, and it's gonna take a number and returns a result. So let me run the Protobuf gRPC tools. So it takes a input path, where did you put your proto files, and then it takes another parameter, um, which is the individual proto files that you want to convert or uh, parse, and then Python out. You can, if you are implementing in Go, you can put Go out, and basically it will generate Go interfaces. In our case, we'll use Python, so it's gonna generate Python interfaces for us to implement. And then gRPC Python out. Sorry, 32. So yeah, generated two files. So basically, it's just an interface for us to implement the client and the server. And for each client, it needs a stub before, when they call the service. Every client needs a stub, and they also provided the interface for, yeah, the actual service, and it gave us an interface with methods. Later, uh, we can use all of this. I'll just show. And then this one you don't need to worry about this generated file. Basically, gRPC uses this internally. The gRPC framework does the unmarshalling and marshalling internally. So this is what it used. So basically, this is where it converted to binaries and from and to desired format. So yeah. So now we'll create a server, and we will implement the interfaces in here. So gRPC SPD port will import all of the generated files. Then we need to create a class that's gonna inherit the service. So this one, otherwise it's gonna throw an error. And also we need the method. We need to inherit the methods inside that class. So we're gonna inherit that, and then we'll implement the method square root. It's gonna take, yeah, VS already implemented it for us, so because I downloaded plugins, so it already understood. But basically, we'll implement the square root method. It takes a request and context, and inside we define the logic of the square root. So request that input times request times to itself to compute the square root, and it's gonna return result type. So type was resulta. Okay, and then we'll create a main method. So gRPC server gRPC dot server, then future. Sorry, I forgot to import features from concurrent. Import features because we need the thread pool. for this server. Features, thread pool, max executor, max workers 5. So basically we want the server to cater 5 concurrent threads, 5 concurrent requests. And then server, we need to add this service into the server. gRPC 2. So this one is already provided, this method, by gRPC. So it's gonna take instance of this object and the server, and then we'll expose the server in localhost, expose it into this port, a high port, to make sure it's available. And then we'll start the server. So by the way, this is a non-blocking call, meaning all those 5 threads can run in parallel. But in this sample, I'm gonna make it a blocking call, meaning the thread caller on these steps is gonna wait for, we will gonna wait for that thread caller itself to terminate his process. So yeah, just to make it simple, and we need to make sure it's running. Server started, we need this, just a print. So yeah, let's see if the server will run. The server, okay, so it started. So now we can create the client. Depending on your choice, in this demo I'm gonna use Python for gRPC. Import those. Yep, def run. So we're gonna create a stub. Servers that insecure service, insecure channel. We use localhost in our machine. So basically, each client needs a stub for it to communicate to the service. Before it can call the service, it needs a stub. So yeah, so the stub interface is already provided here. We just need to implement. Where's that stub located? Stub, oh, this one. Stub, it takes a channel as parameter. So these are stub, and then from stub we can call the method that we just defined in Proto, and we just implemented it in the server. So this server could be running in Cloud Run or Compute Engine, and the service is being catered there, and the method is defined there, the logic is defined there, but you can call that method that's running remotely in the client. So I'm gonna call that, I'm just gonna do that. So the square root is taking a number type that has a parameter of input. Let's say I want this to compute the square root of 3. Then we'll just print that shit. Oh, sorry. Response resulta, and then Let's see if this thing will run. We'll make a request to the server. Ay. Hey, what's happening? Okay. Sorry. Resulta is not defined. Aha. Okay, let's run this server again. Then we'll make a request to the server. Boom. You got 9. So you just call the service from the server. Say for example we want to compute the square root of 749. But if the server is down, let's say for some instance the Google Cloud Run for region Asia Northeast is down, for example, you try to create a request, then it's down, failed to connect to all addresses. Then once the server is backed up, you can cater the request again. So yeah, you can I'll say try to play around with this using different interfaces platform. But basically, I hope this introduction help you quite understood what's the usefulness of gRPC. And yeah, this tool is getting popular nowadays, so I thought of creating some introduction. So yeah, I hope you can use this in your microservices if your company is implementing those type of structure. So yeah, see you again on the next video.